Hello everyone. Today I will present our work, Balanced Plot of Calibrated Experts for Long-Tail Recognition, accepted at CVPR 2023. Real-world data usually follows long-tail distributions. However, during inference time, we want a balanced classifier that can perform well across all classes. We would also like for this classifier to be well-calibrated. Overall, this is a challenging problem involving a label distribution shift. To address these issues, we propose BalPoE, a simple framework composed of multiple expert models, each of them addressing diverse target distributions. We will show that our skill-diverse ensemble is not only unbiased for the balanced distribution, but also well-calibrated. Let's now discuss BalPoE in further details. To learn a diverse set of expert models, we propose a family of parametric logit-adjusted losses. We show that by enforcing an increasingly larger pairwise margin for tail classes, we can easily parameterize multiple expert distributions. Finally, the combined ensemble loss is the average of all the expert losses. We propose to aggregate expert models by simply averaging all the responses before applying softmax. We showed that BalPoE attains the average bias of all its experts, parameterized by the lambda bar parameter. Then, by ensuring that lambda bar is 0, we obtain an ensemble that is unbiased in the sense that it's feature consistent for the balanced distribution. From a statistical perspective, we observe that logit adjustment assumes a base optimal classifier for the training distribution, and such classifier should be well calibrated. In practice, we explore the use of mixup to meet the calibration assumption. Empirically, we observe that mixup regularization helps calibrating our expert models, reducing the key diversions between the target priors and the marginal distributions estimated using expert models. Now to the experimental part. In our experiments, we compare our approach against recently proposed methods and the several long-tail benchmarks, including large-scale datasets like ImageNet and iNaturalist. We observe that the BalPoE with 3 expert models achieves state-of-the-art results all across the board, surpassing previous works by significant margins. Interestingly, our ensemble gracefully improves performance as we add more experts, needing only 2 experts to match or surpass performance of more complex systems. Importantly, BalPoE brings substantial benefits for all classes, showing a remarkable 20% boost in performance for the group of tail classes. Here we go beyond the standard balance benchmark and investigate if BalPoE is robust under different distribution shift during inference time. These test distributions range from forward long-tail settings, similar to the training data, to the uniform distribution, and even challenging backward long-tail scenarios. When the test prior is unknown, our approach presents very strong results under multiple scenarios, beating other baselines in most cases. Furthermore, when prior information about the test distribution is available, our well-calibrated model can effectively exploit it, surpassing single expert models like LADE, or alternative approaches like SAID, which estimates the prior from test data. Finally, we showed that BalPoE is significantly better calibrated than previous long-tail approaches, including the expert frameworks. Interestingly, we observed that recent logit-adjusted methods like balance softmax, although they are feature consistent, they can still be poorly calibrated. We address this issue by training our expert framework with mixup, obtaining a high-performant and well-calibrated approach for long-tail recognition. When comparing with earlier long-tail approaches, which focus on calibration, we observe that BalPoE presents strong results in terms of performance and calibration, even without mixup regularization. By regularizing our logit-adjusted experts, mixup simultaneously boosts generalization and calibration metrics to achieve an even stronger model, highlighting the importance of well-calibrated experts. In conclusion, we extend the logit adjustment formulation for training a balanced broad of experts. We also showed that the ensemble is feature consistent for the balance error, given the simple constraint is fulfilled. And finally, we find that the X calibration is important for achieving an unbiased ensemble using naive expert aggregation, and use mixup to achieve this goal in practice. Thank you for listening, and don't forget to take a look to our project page by following the QR code or the link in the description below. Bye!